Hi guys, let's talk about conduction, convection, and radiation. So previously we talked about all the different types of energy, right? One of which was thermal energy, which is heat, okay? And that's all about like particles moving, right? Molecules and atoms moving and bouncing around. And so when they're really cold, they're going to move really slow, right? When they're hot, they're going to be really excited, okay? And so we're going to just focus in on thermal energy and talk about how thermal energy moves, how heat moves from one object or space to another, okay? So let's dive in. So heat is thermal energy that's being transferred from one place to another, right? This is the law of conservation of matter. Thermal energy equals the total energy of all of the moving particles, right? So heat transfer happens when heat goes from the hot object to the cold object. That's how heat's always going to move. It's going to always go from something hot to something cold, right? It's going to radiate from something that's hot, okay? Here's the law of conservation of energy, right? It's never created or destroyed. It's just changing form, right? We talked about how like energy, electrical energy from your phone, right? It's charging, right? It's coming from the outlet and it's going into your phone and making sound, light, and heat energy. So that's the law of conservation of energy. And so the same thing's going to happen with heat, right? Heat does not just appear or disappear. It's going to move from one thing to another. A thermometer, right, it measures particle motion. We talked about how excited they are, and that's what a thermometer does, right? The thermometer has a little bulb at the bottom, and so stuff will bounce and hit the little bulb. And if something is cold, they're not bouncing as much, so the alcohol doesn't rise as much, right? If they're really excited and it's really hot, right, they're bouncing around and they're hitting that little bulb a lot, causing the alcohol to rise up. So let's talk about the first way that heat can transfer, which is radiation. And this is happening through empty space, okay? Radiation means that heat is traveling through space. Like this guy right here is cooking his marshmallows, but he's not touching the flame, right? He's just using the heat that's radiating off of the fire to cook his marshmallows, to melt his marshmallows, okay? So it's traveling through space. It's kind of like if the stove is on and or the oven is on and you just walk by and you can feel the heat from the stove and the oven even though you're not touching it, that's radiation. Or maybe somebody's barbecuing, right? You're having carne asada. And so you're you walk by the barbecue, right? And you can feel the heat coming off of it, but you don't touch it, right? You're not actually touching it. You just feel the heat. Or you walk by a fireplace and you can feel the heat coming off of it. That's radiation. It's traveling through space. The same thing happens with the sun, right? In the summer, it's super hot and you can actually sometimes feel like you're getting a sunburn. Like you can feel the heat on your skin. That is radiation, right? The sun, it's traveling through, the heat from the sun is traveling through space to get all the way to Earth. Okay, second one, convection. Convection has to do with currents. And we'll talk more about this when we talk about the convection currents in the mantle. But basically, this has to do with density. Stuff that is hot is less dense and it wants to float up, okay? Stuff that is cold is more dense and it wants to sink. And so that can create a current traveling through the Earth's mantle in a boiling pot of water or even the atmosphere. So for example, here we have the sun is heating the dark ground. Maybe you've seen this when it's like really hot outside and you look out over at the street or a highway and you can see like little waves of heat coming up off of the asphalt. That is convection, right? It heats the air up above the ground right here and it floats up because stuff that's hot is less dense, so it wants to float. It gets away from the hot ground, right? And it cools off and it sinks back down. And this is what causes clouds to move. This is what causes weather to move. And so we have this convection current. Same thing in this boiling pot of water, right? It's really hot over here. It floats up, gets cooler, comes back down, and it creates these convection currents as the water heats up, tries to kind of evenly heat up, right? So convection has to do with currents. The same thing happens in Earth's mantle, right? We have the core actually heats the magma in the mantle and causes it to float up. When it gets near the crust, right underneath the crust, right, it cools and it wants to sink back down. And this is convection currents in the mantle that cause the plates on top to move, right? Because of that's what causes plate tectonics, okay? So convection has to do with currents and it has to do with mixing. Another example of this is hot air balloons, right? Here's a little basket with some people in it, and this is a very cool looking hot air balloon, right? This is how I remember which one sinks and which one floats, right? Hot air balloons are gonna go up, right? So hot air balloons have regular air in them. They do not have special air. It's not like helium or anything like that makes it float like in balloons. This is just regular air that's being heated by a heat source down here at the bottom. And so it heats the air inside the balloon and it wants to float up, right? Because hot stuff floats up. And so when the hot air balloon pilot wants to come back down, they turn down the heat so that the air in the balloon cools down, right? And it's going to want to sink back down. And so that's how they get back down to the ground. Then finally, conduction. This is kind of the easiest one. This is touch, right? And so whenever everybody's burned themselves like on the stove and stuff like that by accident, right? And so here we have whenever stuff is touching and the heat transfers, that is conduction, right? So here you have somebody holding a metal rod in a candle and heating it up, and then the heat's going to transfer, you know, because it's touching, right, from the flame to the metal rod and then to you. This is like when you're cooking an egg, right? The egg is touching the pan, which is touching the burner on the stove, and so that's through conduction. The objects are touching, and so the heat moves because those objects are touching. So here's a review of everything, right? I talked about how like you just walk by the stove without touching anything. You can feel the radiation coming off of the heat. There's convection currents mixing happening within the water that you are boiling. And then this guy's touching the hot handle and burning himself. And so that's conduction, right? Conduction is going to be through touch. Convection is mixing, and radiation is through space. Let me know if you have any questions, and thanks for watching.